Okay, now we're in section 3.6, which is about compound inequalities. This should be the heading at the top of your notes. So the goals, which you do not need to write down, are to solve and graph inequalities containing the word or, and to solve and graph inequalities containing the word and. Inequalities with the word or, so this one would be like x is less than negative 2, or x is greater than or equal to 1. So on a number line, this is 0, this is negative 2, this is 1. X is greater than or equal to 1 is going to be graphed this way, right? And it's a solid dot. And x is less than negative 2 is going to be graphed this way, and it's an open dot. So it's x can lie in this plane or it can lie in this plane. So it's two separate graphs. However, to solve and graph inequalities containing the word and, it contains the overlap of two graphs. So if you had x is greater than or equal to 3 and x is less than or equal to 7, on a number line, if you have 3 and you have 7 over here in the middle, well, x is less than or equal to 7, so I'm going to have a dot here, and I'm going to be shading this way. And x is greater than or equal to 3, I'm going to have a dot here that's also solid because it's greater than or equal to, and it's shading that way. So x has to fit both of these limits, so the shading is in the middle. So let's look at some examples of writing a compound inequality. So what compound inequality represents the phrase in these following examples? All real numbers that are greater than negative 2 and less than 6. So we'll say all real numbers x, right? This is our x. X is greater than negative 2 and x is less than 6. So this can be actually written as one inequality instead of two separates because it says and. So you put the x in the middle and you go x is greater than negative 2, so we just flipped this one here, and x is less than 6, x is less than 6, so that's this one here. So now we have these two separate inequalities written as one compound inequality. So when it's the word is and in the middle, you can write it as one inequality in these with the three different parts. So let's look at part B. All real numbers that are less than 0 or, so less than 0 or greater than or equal to 5. So all real numbers x is less than 0 or x is greater than or equal to 5. So this one doesn't fit, right? You can't write this as one compound inequality because like this one up here, it goes in order, right? Negative 2, then x, then 6. Negative 2 is less than 6, so you can write that in order as one inequality. However, x is less than 0 on a number line. If this is 0, x is less than 0, it's going to be that way. And then if this is 5, x is greater than or equal to 5 is going to be written that way. So they're two separate inequalities. And also note, I'm naming the all real numbers as x, but you can use any variable that you want. Okay, so now if we want to solve a compound inequality involving and, if we had, let's look at an example. If we had negative 3 is less than or equal to m minus 4 is less than negative 1. If we wanted to know what the solutions are of this inequality and graph the solutions, well, you solve these separately. So you would solve this one. So we have negative 3 is less than or equal to m minus 4. And then you solve this part. So we have m minus 4 is less than negative 1. So let's solve those just like equations, right? So we have plus 4 plus 4, negative 3 plus 4 is 1, is less than or equal to m. And over here we have plus 4, m is less than negative 1 plus 4 is 3. So now we can rewrite this as m in the middle. M is less than 3, that's this one. And m is greater than or equal to 1, that is this one. And now to graph this, if we have 0, 1, 0, 1, 2, 3. Well, m is greater than or equal to 1, so we have a solid dot here, and it's going to shade that way. And m is less than 3, and it's going to shade that way. So this is our graph, with a closed dot at 1 and an open dot at 3. To solve a compound inequality involving or, you just have two inequalities, so we would have 3t plus 2 is less than negative 7, or negative 4t plus 5 is less than 1. So you just solve these separately. So minus 2, we have 3t is less than negative 9, right? Negative 7 minus 2 gives you negative 9. Divide by 3, we have, we have t is less than negative 3. And then we have, minus 5, negative 4t is less than 1 minus 5 is negative 4. Divide by negative 4, divide by negative 4. T is greater than 1, right? Don't forget to flip the sign when you divide by a negative number. So now on a graph, we have negative 3, 2, negative 1, 0, 1, 2, 3. So t is less than negative 3, so we're going to have an open circle and graph it this way. And then, or t is greater than 1, so we're going to have an open circle and graph it this way because t is greater than negative 1. So that's how you solve a compound inequality involving or. You just solve the two separate inequalities and graph them separately on the same number line. Okay, and we have one last thing to talk about, interval notation. So this is just another way of expressing an inequality once you've solved it. So if you had x is greater than or equal to 2, that was your inequality that you solved. The interval would be 2 to infinity. This is the infinity symbol. And since it's greater than or equal to, since that's the sign we're talking about, it's inclusive of 2, you use a bracket. And infinity, that's just open-ended, right? It goes on and on, so you use a parenthesis. So this is the interval. If it was x is less than 2, you would have negative infinity, right? X is anything less than 2, up to 2, but it's only less than, it's not less than or equal to, so you use a parenthesis because it's exclusive. So, parentheses are used with the less than or greater than sign, and brackets are used with the less than or equal to and the greater than or equal to signs. So this is interval notation. So have these in your notes, and on one last thing, I'll give you a few practice problems, and then I will see you in class. Okay, these are your 4 practice problems. So number 1, write a compound inequality that represents each phrase and graph the inequality. So do A and B for that. Number 2, what are the solutions of negative 2 is less than 3y minus 4 is less than negative 4? Graph the solutions. Number 3, express the following inequalities in interval notation. And 4, this is a challenge problem. Write the inequality of the following interval. So that's it. Have your notes and then these 4 problems done. I will see you in class.